Welcome back everybody. In this video we're going to look at option 3 for allowing traffic outside of the fabric, which is going to be using a common VRF on the border leaves and essentially doing route leaking into that and out of that common VRF. So the connection that the firewall is going to have with the leaves will be kind of generic rather than specific to one tenant or another, so we'll be able to use it essentially for multi-tenant environments like we have here. So the configuration for the fabric is how it was at the start of the last video. So we've separated the VRFs again so we don't have any route leaking. So let me just show you the section. You can see it up there, but the BGP configuration is like that and the VRF configuration is that. So we're no longer doing the route leaking between tenant 1 and tenant 2. That's the same in here as well, BGP and VRF. So we've essentially unconfigured that route leaking because it adds additional complexity when we're looking at allowing access outside the fabric with, if we get routes in one way, it could circle back and advertise into another VRF that we don't want it to. Where you can combat that with route maps, that's quite advanced and is outside of the scope of this video. So let's have a look at the firewall configuration as well, because that has changed slightly. We've gone back to a single interface rather than sub interfaces. Same on the firewall in DC2. And if we have a look at the virtual router configuration, it's pretty much BGP peer group. It's back to how it kind of was with the one peering, and we've called this common. So that's going to be the name of our VRF on the leaves. So let's jump on to DC1 leaf 2 and start with some configuration. So first off, we need to create this new VRF. So VRF context, we'll call it common. This is also actually going to need its own L3 VNI as well, and we'll configure it without and show why it does need it when we get to that point. So let's set the RD to auto. We will set the VNI for the moment. We'll go 900 990. We'll come into address family for IPv4 unicast, and we'll say root target both auto. We won't do the EVPN command on here because we're not really going to have EVPN routes in here from a /32 perspective, not in here that are going to be exported at least. So we'll do some import commands afterwards for the other VRFs, but for now we'll just do both auto without the EVPN. So for this we're going to use eth1/5 again. So int eth1/5. We will no switch port it, and we'll no shut. Oh. It's being slow on me. No shut. Cool. So VRF member is common. Going to be IP address 10.60.60.1/30, and then what we should be able to do is ping 10.60.60.2 from the VRF of common. We can. That's a good sign. So now router BGP 100 VRF common. We'll do neighbor 10.60.60.2. The remote AS again is 150 in this data center for the external peering, and we'll enable the address family of IPv4 unicast. So if we do a show BGP VRF common IPv4 unicast and just look at the summary, we can definitely tell that the neighborship's up. It's been up for 3 seconds, and we can see that we are receiving the default route that we would expect from the firewall. If we have a look on the firewall, we should see the peering has come up, but we won't actually see any routes being advertised from the fabric. So looking at BGP peer, we can see that's established. The local RIB has just got the default route, which has been locally originated. So let's continue and do a bit of route leaking. So if we look at the VRFs at the moment, so we've got common, we've got tenant 1 and tenant 2. So what we want to essentially do is we want to get the default route out of this common VRF and into the two tenant VRFs, and then we want the tenant routes to come out and into the common VRF. So what we'll do is in tenant 1 we will address family IPv4 unicast, and in here we will route target, and we're going to want to import, and we're going to want to import 100 and then the L3, the VNI of the common tenant. Do that. Then we will come into tenant 2 and do the exact same thing. So this is where we've used the route target of auto. That's essentially what it does, as I've alluded to previously. It uses the autonomous system number as the first, and then the VNI is the second half of the route target. So what we should see is if we do a show BGP VRF tenant 1 IPv4 unicast, we see now that we have a default route in there, and if we do a show IP routes VRF, in fact tenant 1, we should see it here, and we do, and we'll see that it's via the common tenant, which is a good sign. So that's being leaked from the common tenant to the tenant 1, and we'll also see that on the tenant 2, which we do there. So that's the one way. If we look at the common tenant currently, or the common VRF currently, we don't see any 10.10 or 10.20 routes in here, so we need to do the other way essentially. So router BGP, in fact no, VRF context, common address family IPv4 unicast, and then we need to say route target import, and then will be 100, and then it's 900 101 900 102, and they are the VNIs for, or the L3 VNIs for tenant 1 and tenant 2. We do also, and let me just show what we've currently got. If I now look at the common VRF, we can see now that we've got 1010 and we've got 1020, but we've only got the /24s. Really what we need is we need the EVPN routes as well, and if we do EVPN on the end of here, what I want to show is that nothing actually changes. We don't gain any additional routes from doing that, and the reason for that is because this common tenant isn't really an L3 VNI yet. We haven't created an SVI, we haven't created a VLAN, and we haven't associated the VRF. Until we do that, those routes will not appear in here other than these /24 routes. These /24 routes are essentially IPv4 unicast. The EVPN is for the L2VPN EVPN address family, and what we want to see in here is we want to see the /32 routes, because what they will have is they will have very specific parameters on them that tells this switch which leaf they live on, rather than them just being essentially directly connected to this VLAN, which isn't going to work for us, because we've potentially got multiple leaves and they could be on any of those leaves rather than being directly connected to this one. So what we need to do just to prove that is, in fact, let's have a look at leaf 1 as well, because there's an extra bit of configuration that we need to allow that default route to propagate. So if we currently have a look, tenant 1, tenant 2, we don't see the default route on here, even though it's being advertised in here under, let's have a look, tenant 1. We can see the default route is in here, but it's not being advertised to the other leaf, or well, to the spine and then to the other leaf, which is a little bit odd, but there is a reason for that. There is a command that we need to add under the VRFs for tenant 1 and tenant 2, which essentially permit the switch to advertise routes that have come from another, what it considers VPN. So essentially the route is coming from the common tenant into the tenant 1 and tenant 2, but we need to say under the tenant 1 and tenant 2 VRFs that you are allowed to essentially let that route go further than you. So what we need to do is come into VRF context for tenant 1, and again this is only on the border leaves. Address family of IPv4 unicast, and we need to say import VRF advertise VPN, and we need to do the same thing under tenant 2, import VRF advertise VPN, and then if we come back here we should see that pretty much immediately we've now got a default route. So we're now saying yes, you're allowed to advertise that out further than yourself. So if we jump onto a PC in DC1 and just do a ping to 8888, we would expect this to not work. And the reason why this isn't going to work is because we don't have those /32 routes on the common VRF on the border leaf. So what I'm going to do is I'm going to set this running with 1,000 pings, and then while we're doing this configuration we can pop back and see at what point the pings start working. So what we need to do is essentially the same steps as creating an L3 VNI. So we need to create a new VLAN, so we'll create VLAN 990. We'll say the VN segment is 900.990. We will create a interface VLAN 990. We will no shut it. We will say VRF member is common and IP forward. If we exit out of there and come into the interface NVE1, we can say member VNI, then this associate VRF. And if we pop back in a short couple of seconds, we should see, yep, those pings start to work, which is what we'd expect, because what we'll see now is if we do a show IP route VRF common, we'll see, in fact let me make that a bit bigger. Yeah, we'll see now that we've got these /32s in here, and you'll see that instead of it saying, it's attached, it's going to be via, another leaf. I mean, that's the border gateways up at the top, but here we can see that these are via specific leaves, which is what we wanted. So that is good. So from a DC2 perspective, if we have a quick look, what we can see, so show BGP IP, VRF tenant 1 IPv4 unicast, we can see that we do see a default route over here. So this default route is being advertised over the DCI. So we shall see whether something in DC2 has connectivity, and it does, which is a good sign. So that's essentially coming over the DCI because we haven't configured anything yet in DC2. Let's also check something in VLAN 1001. We can see that that's working. We'll try something in VLAN 1001 but in DC2, and again we can see that that is working as we would expect. If we take a closer look at this route, we can see the information about it. We know where it's come from, which leaf it's come from, and that it's come through a route reflector, which will be the spines and everything like that. So it's a type 5 route as well, because it's just network reachability information from essentially a prefix rather than a MAC and IP mapping. So cool, right. So now we just need to do the same on DC2, But what we'll have a quick look at is we should now also see on the firewall, which conveniently wants me to re-log in. We should see on here that we have additional BGP routes. We can see that we do have the /32s on here, which isn't really required as far back as the firewall. We only really need the /24s on here. It's the /32s that we need in the common VRF on the border leaf. So you could do a route map exercise on the leaf to only allow the /24s or whatever the bigger subnets are out. So cool, right. DC2 leaf 1 is the border leaf in DC2, so let's do similar configuration on there. So let's create this VRF first. So VRF context common, we'll set the VNI to 900, 990, we'll set the RD to auto, address family of IPv4 unicast. Set the route target for both to auto. We'll also, while we're here, we may as well say route target import 200, 900, 101, EVPN 102, EVPN. So that's us saying that for ourselves we're auto, and then we're going to want to import the routes from the other two tenant VRFs local to this switch, and again we're specifying 200 because we're in DC2 and that's the autonomous system number. Let's, while we're here as well, VRF context tenant 1 address family IPv4 unicast. We will also do the import VRF advertise VPN on here, and we'll also import, in fact, route target import 200 space there. So essentially that's us saying you're allowed to kind of give these routes to other people, and then I also want to import the default route that will live in the common VRF. So we'll do the same thing for tenant 2. We'll say import VRF advertise VPN, and we want to route target import 200, 900, 990. Cool. Let's configure ETH1/5. So we'll no switch port it, we'll no shut it. We'll say VRF member is common. We'll set the IP address to 10.61.61.2/30. Oh, actually no, we're .1 on here. And we will come into BGP. So router BGP 200, VRF common. Neighbor is 10.61.61.2. The remote AS is 250. We'll address family IPv4 unicast to enable it. Cool, and then if we do show BGP for VRF common IPv4 unicast summary, see that's come up, and then in here we can now see that we've got the default route, and we've also got other bits in here. So let's also do the L3 VNI configuration. So VLAN 990, VN segment 900, 990, exit, interface VLAN 990, we'll no shut it. We'll say you're a member of the common VRF, we'll say IP forward, and then last but not least, interface NVE1, member VNI associate VRF. So if we have a look, show IP routes for the VRF of common. Make that a bit prettier. There we go. We'll see that in here we've got our default route, which has come from the firewall. We've got our /24s, so there and there. And then we've also got all of the /32 routes in there, which is what we wanted. If we have a look in the other VRFs, so show IP route, VRF tenant 1, we'll see in here that we've got our default route and it's via the common tenant or the common VRF. If we have a look on leaf 2, do a show BGP VRF tenant 1 IPv4 unicast, we see our default route and it's via the border leaf in DC2, which is a good sign. So let's do some verification. So PCs in DC2, PC3 and PC4, let's have a look. We can get out to the internet, that's a good sign. Then let's check the other VLAN, and we can also get out to the internet on there as well. Let's do a trace. We'll see again that we're going local, so we're 10.62.62, and then let's do that as well in DC1 and make sure that we're going local as well. And we are, so we see 10.60.60 there. So DC1 is using its local firewall, DC2 is using its local firewall. Let's just, for simplicity's sake, or for completeness sake, should we say, DC1 leaf 2 interface ETH1/5. We'll shut that down, so we'll say that there's a failure in DC1 somewhere, and then let's check that from DC1 machines we can still get to the internet, and we can. If we do a trace on that, we can see by looking at that trace route that we're going over the DCI up at the top, and we're using the firewall in DC2. And if we no shut that and give BGP a second to work things out, we should then be using the local DC again, 6060.2, which is DC1. So essentially, in order for us to allow that connectivity, we had to make the common VRF an L3 VNI, which seems a bit kind of over the top, but because we need those /32 routes in there, it's kind of a requirement. You can't just have a standard VRF paired with the firewall, unfortunately. So that's essentially it for this multi-site fabric setup. We've essentially set the fabric up and we've given access outside of the fabric, so that's all there is to it. If you have any questions or any comments, please leave them below and I'll do my best to answer them. Thank you.